is our presentation on a bike pedal axle evaluation.
The bike pedal axle is there listed in blue. It's a member that connects to the crank arm, and we wanted to look at the forces that it experiences and why it doesn't fail.
This problem, we're just looking at static loading and cyclic loading on the bike pedal axle itself. Measured values that we found for the bike pedal axle are that it has a 1/2 inch diameter and the total length of it is 4 inches.
Here are some of our research values. Our pedal axle used a forged steel alloy, and using the Shigley text, we found that the ultimate strength was 118 kpsi, the yielding strength was 102 kpsi, the A, B, and Ka values from table 6.2 and 6.4 were 2, negative 2.17, and 0.868. Some other values we found were the forces that would be applied to the pedal. In the cyclical loading case, this was 75 pounds and 25 pounds for the maximum and minimum, and in the static loading case, it was 600. Calculations, some assumptions we made were that the system simplifies to an evenly distributed force on the axle, that it could be modified by a 1/2 inch diameter cylinder, that an equivalent force could be applied to it, the axial tension would be negligible, and that the bending load is equal to the equivalent force. This is an example of how we modeled the problem. So a distributed load is pictured on the left, and the equivalent force at 1.75 inches is pictured on the right. To calculate the factor of safety against yielding, we had to find the sigma prime value. So we did this by finding the equivalent force, then the bending moment, the second area moment, and then since sigma y and tau xy are both equal to 0, the sigma prime simplifies to what sigma x is, and we use that with the sy value previously mentioned to find a factor of safety of 1.2.
Loading, the assumptions were very similar to that of static, but we also needed to assume that the axle only experiences bending and that the temperature is constant. Personal testing for cyclic loading, it was found that the minimum force occurs at top dead center and that the maximum force occurs at bottom dead center. By defining the coordinate system to be attached to the axle, which is fixed to the crank arm, the sign of the forces will be opposite. This makes F max positive and F min negative. To find the factor of safety, we used Goodman criteria, which involve finding the maximum bending moment for the maximum and the minimum, as well as the maximum minimum stress, and then the alternating and mean stresses. Factor of safety, we also had to find the SE value and the SUT value, and then from there we found that the factor of safety was 4.2.
With a static loading factor of safety against yielding of 1.2 and a cyclical loading Goodman factor of safety of 4.2, we can confirm the pedal axle will not fail. The axle is predicted for infinite life because the Goodman factor of safety is greater than 1 at 4.2. The axle is also safe against yielding in its maximum load case of 600 pounds. This explains why a pedal axle to crank arm connection is unlikely to fail. These are our 3 sources. Thank you for watching.